Good day, viewers. You're welcome to my YouTube channel, Maths with Adevic, and my name is Victor Adewale Adeleke. Yeah, our major focus is to teach you mathematics from the basic rudiments, even up to tertiary institution. And if you are yet to subscribe to this channel, do well to subscribe, hit the notification button, like and share. And as it's very important so that when I post videos like this, you'll be notified immediately. Now, following my series in my other class, I've been teaching indices and logarithms. Now, as I always say, it's not really a problem. Maths is not really a problem. Remember, I always say that in the beginning of my classes. Maths is very, very simple. So, in my other class, I explained indices and logarithms, and I proved out these two theorems in indices and logarithms. But today, I'm going to explain other properties that can be called theorems or properties of logarithms. Now, if n is equal to n to the power of x, then log n base n is equal to x. If you remember, I didn't explain anything about the base in my other class. I only talked about, I told you about natural log, that they don't have, that whenever you see a logarithm like this, maybe log 5, and they don't give you any log, you have to note and understand that there's a, and this is called a natural log, which is natural log 5, and it has a constant base of what? Of 10. And you can punch that to your calculator, but that's what your calculator naturally understands. That's why it's called the natural law. Now, this other law, if you have the base and the subject the same, then it must be equal to 1. If you say log n base n, then automatically it becomes 1. And I'll be explaining how these principles work in this class today. Another thing you must also understand is that log c raised to the power of n is written as n log c. Log c raised to the power of n is taken as what? As n log c. Understand that concept. Now, I'm going to firstly try to prove this one for you so that you understand how it works. These are questions that I promised that I will solve some questions. These are questions from JAM, and I also told you to drop questions on my comment section. Any question you find that you're finding as a problem from indices and logarithms, drop them on the comment section and I will provide a solution. Now, let's quickly try to first of all prove that law with this first property here. If n is equal to n raised to the power of x. So now if n is equal to n raised to the power of x, now what you must know is that take log of both sides, the golden rule of mathematics, whatsoever happens to the right hand side happens to the left hand side. So we have that log n will be equal to log n raised to the power of x. And I believe in my other class, because I'm making references to my first class, very important. In my other class, I explained that if you have anything like this, raised to the power of x, this x can be inverted to the back, and I also give it as a log here, which is the last property, so that we will not have to be making several references to that. You can just quickly look at it here. And if you have not watched that video, make sure you watch it. It is very important so that you will understand properly what I'm doing here. Now, we have video like this. Now we have log n is equal to, as I say, it will be inverted, x log n. So log n is equal to x log n. Now from here, what we are going to do is what we call the change of base rule. We are going to apply the change of base rule. What does the change of base rule mean? The change of base rule is a kind of rule. Let me explain it here. It's a kind of rule. If we have log 5 base 3, and we want to convert this log, this is base 3 now. We want to convert it to a base of 10. What we are going to do is that it's very simple. Just understand that log converted to base 10 will become 5 base 10 all over log 3 base 10. This is exactly what you are talking about. And that's what I did here. You can see this log here under the properties. Log n base c. I want to convert it to a base of a. So what did I do? I have to make sure that the n, which is this, the subject, stands. Then the base becomes the subject and the denominator. Then we take a new base, any kind of base we want. We can plug it. We can put base 9. We can put base 8. We can turn it to any base as far as we have moved it like this. Very important. It is a very powerful and smart way of solving this stuff. Now, once you understand this, now let's apply that law again. Now, what we are going to do now, we are going to convert these. This already in on a base of. This already in a base of 10. So we want to convert it to a base of n. Now let's try to convert to the base of n. If you are doing that now, we now have that log n base n all over log 10 base n. Like I said, this is Okay, let me put the bases. Each one is base 10, naturally base 10. Naturally base 10. So when you have changed this base now to become log n, which is the base, the subject becomes the numerator, log n base n, then divided by log 10. The base becomes the subject at the denominator, as I earlier stated. Then you put your n, which is the new base you are changing to. So in this case, I will change this base 10 to base n. So the same thing applies here. You have your x, then this one we are changing to n. So we have log n base n all over log 10 base n. Now, there's a rule of mathematics that is a system of mathematics that you need to understand. Whenever we have the same denominator, if we have 5 over 3 is equals to x over 3. 3 can cancel 3 from the denominator because they are both at the denominator. Keep this one at upstairs and you gradually become a genius in mathematics. So 3 cancels that 3, it helps you for speed and accuracy when you are, especially in competition centers. This is very, very adequate and helpful. So what happens now, the same rule applies here. This cancels this. So what do we have? So we have, do not forget that n base n, whenever we have the same base and the denominator, it becomes what? It becomes 1. So we have x1, which is x times 1. And x times 1 is what? Is x. Equals to what? Equals to log n base n. You can see now I've proven this law. So if it has been proven that if n is equals to n is power of x, it has been proven that what? That log n base n will be equals to x. So this is one method law that we'll be using to provide solutions to very many questions. And just that's a quick one. I have to just quickly do that so that you understand how this stuff works. Now once you have done that, now let's quickly solve these questions because as I promised, we'll solve some questions. So let's quickly solve this question. This is a question from by JAM 1999. Yeah, question 1. That was the first question we solved that year, 1991. So I'm going to quickly attempt this question. We're going to attempt it together using the laws that have been provided, that have been taught, that have been explained. I think I've majorly touched every of these laws. Yes, of course, I proved out this 2 yesterday. I just proved out this one. This one has been explained to prove this particular one. So let's try and solve this question now. Let's try and solve this question. So it's very simple because they all have the same base. It makes it very simple and very easy. Now you can see, let me write the question solution 1. Let's evaluate this question. So what are we going to do? I don't want to write the question again. The question is already there, so you can look at it. What we are going to do immediately is that because it's plus, we are plusing this log, these two together. Remember the law of addition or product law. When you add these two together, something becomes the product. So automatically, which means that these two, because they are of the same base, do not forget this one, they are of the same base. They are both of base what? Of base 10. Very, very important. But this one, they are both of base 5. So what we are going to do here is that we are going to solve this question. How are we going to solve it? What you do is follow the law. Log, it becomes log n base n. So log n. So we are going to have log. This one is base. This one was base 10, natural log. But this one is base 5. You put your base 5. Then you have your what? 3 over 5 times. Okay, there's a problem here. Because of these 3 at the back, like I said, n was at the back. So n was inverted to become c at this point. So that's what we're going to do here now. So these 3 will be inverted to this point. We now have 15 over 2 all cubed. So once you have added this, I think they're going to try to put the parentheses properly. Because parentheses is mathematics. If you miss your parentheses, you have spoiled your maths. So that's that. So once you've done that, let me put my minus log base 581 over 8. Okay, let's solve. Now once you've done that, now what you are going to do, what does this one mean? It means the law of mathematics a over b all squared is the same thing as a over b. If you watched my quadratic, when I was doing quadratic equation, I explained something like this times another a over b. So once you do this now, a over b times another a over b, we get it. Now what do we do that? Well, how do we go about that? This is just power of 3. So we are going to make it was cube into 3 places. So when you do that, we are going to have. Okay, before we use that method, let's quickly do something. We still have 5 here. We still have 5. Just hold on, we are coming back to that. We have 5, we have 5. So since we have 5, we are going to apply, and we have a minus. So we're going to use the minus for law, division entirely. So what does that? How do we do that now? Which means that we're going to have that log base 5, all put them in parentheses, 3 over 5 times 15 over 2, 15 over 2 times another 15 over 2 times another 15 over 2, because we are in 3 places. Then what do? They will put your divided by, you can put a deep parenthesis like this, divided by what? 81 over 8. Then you can put your parenthesis like this. Once you've done that, now what do we do? This is in 3 places, so 15 times 15 now will be 225. So we're going to have log of base 5. So we have 3 over 5 times 15 times 15, we have 225 over 2 times 2, we have 4. Then times another 15 times over 2. Then times, I'm coming here now. Simple trick that we were taught in primary school. Whenever you are converting division sign to multiplication sign, you take the reciprocal of the number in the what? In the right hand. So we are taking the reciprocal of this one now. And what's the reciprocal? It turns upside down. So you have 8 all over what? 81. Now once you've done that, what do? Now you have broken it down automatically. Now you can see now we have 225 times this. Now what I'm going to do, we'll say 81 into 225. But if you do that, you have a problem. So let's try and break it down totally. So we're going to break everything down now to the simplest. We have your 5. We have 3 over 5 times, what give you 225? 15 times 15. Let me break it down. 15 times 15 is 3 times 5. 3 times 5 is 15. Times another 3 times 5. Then times another 3 times 5. This is how we break it down for children to understand. Then times, what is 8? 2 times 2 times 2 will give me 8. All over. This is, we started from here. So we have 2 times 2 times 2. Then times 1 will give you 81. 3 times 3. 3 times 3 is 9. Times another 3, 27. Then times 3, 81. Once you've done that, what happens? You cancel out the one that are the same. Very simple as that. So 2 cancels out 2. 2 cancels out 2. 2 cancels out 2. 3 eliminate 3. 3 eliminate 3. What else do we have? 3 eliminate 3. I think that's all we are going to. Okay, another 3 eliminate 3. So once we've done that, what do we have at last? We have just a 5 and another 5. That is what is left. Everything has totally eliminated themselves. So we have just a 5 and another 5, which is 25. So this is how simple we have simplified this. So we have 25. Once you add that, so you can write log 25 base 5 is going to be what? Now because we have 25, what will be 25? 25 is what? Is 5 times 5. 5 times 5, that is 5 raised to the power of 2. So we can say that log, let's just put an equal to. So we're trying to simplify this. So we have base 5 raised to the power of 2. Now remember the law that says that whenever you have a power raised to the power of n, it goes to the back and becomes n. So therefore we are going to have that word. This becomes 2 log what? 5 base 5. And don't forget again the law that also says that was n base n. Whenever we have the subject and the base as the same, it must be equal to 1. So you can now say that word. This is what? 1. So everything here means 1. So 2 times 1, we have 2. That is the solution to that question. Jam 1991 question 1. Now we're going to try another question. I think I want to clean this so that we can continue with the question. I want to clean everything so that we can continue this question 1, but I don't want to waste space. So we're going to clean all of this. Very before I pack this quickly so that we can make everything. So we are done with question 1. Now we're going to quickly provide solution to the question 2. Now what are we going to do here? We have this question. It's expedient that we write the question. So we have 3x minus 1 is 2 equals 5. Now we're going to use the method, this law here, which is the first property after this line, this law. That's what we're going to use. So the law says that whenever we have that log m base n is equals to x, whenever we have that log m base n is equals to x, then we can say that what that n is equals to n raised to power of x. So you don't get mistaken, you can say let n be equals to, let's try try to put these two together now, this one and this one, let's try to put them together. So we have that this one is n now. So we say let n be equals to 3x minus 1. Then we also say that let n be equals to 2. I will say let x be equals to what? 5. Because we're trying to compare these two together. So once you have done that, now we look at this equation. If n is equal to n raised to power of x, if n, so what do we do now? N, this is n. So automatically, we are going to what's n here now? N is 3x minus 1. So we are going to have, therefore, 3x minus 1 must be equal to, what is n? N is 2, then raised to the power of what? Of 5. And 2 raised to the power of 5 is 2 times 2 times 2 times 2 times 2. In 5 places, 2 times 2 we have 4, 4 times 2 8, 8 times 2 16, 16 times 2 we have 32. So we are having what? 32 is equals to 3x minus 1. Take your, transpose your 1, becomes 3x is equals to 32 plus 1. And we have 33. So this is 3x. So to get your x, I will do what? Divide both sides by 3. So we have 3 cancel 3. X is equals to 11. So we have add to x, we are getting x to be what? 11. This is one method to solving that question. There are several methods to solving this particular question. Several methods to solving it. And actually you can use your change of base rule to solve it. Like I always tell students that there's no formula that is powerful than any other formula or more important than any formula. It's all about your application and your understanding of that formula. If you want to use change of base rule here now, let's say we want to use change of base rule. I want to convert this one. All you have to do is to convert this one. This is log 3x minus 1. So we have log 3x minus 1 base 2 equals to 5. Using your change of base rule, it becomes log 3x minus 1 and we have what? Log 2 equals to what? Equals to 5. You have converted this one to what? To log. You have converted to your base 10, which is your natural log. So what do we do now? We cross multiply. 1 times everything here, we have log 3x minus 1 equals to 2 log 5. Once you've gotten that now, very simple, you can take this 2 to the top here. So we have what? It still comes back to normalcy. So when this 2 comes back, inverted back, like I told you, it becomes 5 squared. And we have log 3x minus 1. So what happens? Log cancels out log. And we have 3x minus 1 equals to 25, which is still the same place we got to. Okay, 25 power of 2, sorry, which is what? 32. And we get that, the same thing, 2 to the power of 5. So everything still comes back to the point using what? The change of base rule. It's just all about your understanding of the what? Of the formula or the properties that they are principles, and you still get the same answer. Once you've done that, let's quickly attempt the last question. Move on. Okay, now what we're going to do here, we're going to provide solution to question 3. If log 464 base x is equals to 3, find x log or evaluate x log 8 base 2. Now it's very simple. all you need to do here is just to find the value for x. And once you got the value for x, that's all the problem there. Once you got the value for x, substitute into this equation, into this expression here, x log a base 2, and you get the value straight up and you're done. That's how to provide this. So that was JAMB 2015 question 6. So to do that, what do we do? Apply the law that I just explained. So there are many ways to go about this. You can just use the law I told you. X is now representing your n here. Yes, x is representing n. So and don't forget that from the beginning we say that m will not be equal to what n is equal to x. So that's what we're going to do here. So this is going to be written as 64 is equal to x raised to the power of 3. That is just the trick there. 64 is equal to x raised to the power of 3. And once you've done that, you are done, you are good to go. Now, what you also need to know is that, because I think many of you will be confused with that, 5 base, log 5 base 8 equals to, let's assume y. If you want to rewrite this, it will become 5 is equals to 8 raised to the power of y. Notice this is how it works. If you have log x base 8 equals to 12, for example, x will become x is equals to 8 raised to the power of 12. And these are true assertions that are not wrong at all. If you study them, you find out that they are absolutely correct. Now, once you've done that, now let's go back to this question. What are we going to do to provide a solution for x? Because the question is common sense. This is an equation. They are asking you what number are we going to plug here that will multiply 3 times that will give us 64. I know some of you must have by sight been able to get the answer, but what about you are given a question that is beyond your level of reasoning or assimilation? Now we have x raised to the power of 3. What are we going to do? What is that number that we are going to plug here? Following the simple system of algebra to get the solution, what we are going to do is, what will give me this? I will use 2 ways. If you are blind and you don't know what to do, what I mean blind, I'm not saying blind by sight or blind in mind or stunted in understanding. This is what we are going to do. For example, maybe I'm stunted. Let me assume that I'm stunted in understanding first of all. Now, what I will do is that I will take log on both sides. I'm stunted in understanding, for example. Now I'm having log 64 equals to log x raised to the power of 3. Now once I've done that, what do I do? The log, it goes to the back. So we have what? 3 log x. Then we have here log 64. Now what do? I will say divide both sides by 3, divide here by 3. 3 cancels 3. So we have that log x is equals to what? Log 64 over 3. Now this is a natural log. This is a natural log. So if you press your calculator, you are going to get the number there. That's supposed to be there. Log 64. You get the number. Now what do we do? What you will do here, because they are natural log, you can plug a 10 here. You can plug 10 here. And once you plug 10 there, you can just see that therefore x is equals to, this is 10. So 10 raised to the power of log 64 over 3, and you get the answer straight up. When you punch that in the computer, you are going to get the answer for sure. You can try that, do that, and confirm for me. But if you already know what to do here, now we have solved to this extent. Now to this extent, we have 64 equals to x raised to the power of 3. Now we know that, okay, what will give you 64? We know 2 times 2 times 2 times 2. This is already 16 times 2. This is 32 because in 5 places. Times another 2 will give me 64. So we have how many? I have 2's in 3 places. I have 2's in 3 places. So and these 2, each of the 2 means 4 because this is 4, 4, 4. So I can say 4 raised to the power of 3 is equals to x raised to the power of 3. Once you've done that, now because they are equal powers, what will happen? Equal base must cancel out. What do I mean? I mean that if we have 5 raised to the power of 8 and we have x raised to the power of 8, therefore x must be equals to 5. Perfect. It works perfectly well for all mathematics. So 3 will eliminate 3 and we have that x is equal equals to 4. So automatically it means that this must be equals to 4. If you punch this in your calculator, don't forget this an exponent, because many students make that error of writing 10 log 64 over 3. If you do this, you cannot get the answer as 4. Or you must put it as an exponent to the power of 10. You get the answer 4. This is just the simple arithmetic, the simple system of these indices or logarithms, sorry. And I've already made up my mind that in my next class, in my next video, I'll make sure that I provide solutions to indices questions more like this, more problems like this from our past question over egg and jam. And if you have any problem, do well to put them on the comment section. Do not forget to hit the notification bar, subscribe, like and share. God bless you.